You may occasionally need to reduce the number of cells in a crosstab to ensure that the chi-square test is valid. The best way to do this is to group some of the values for the row or column variables so that the number of rows and columns is reduced. This is easy to do in SPSS and will make your test more reliable because the expected frequency in each cell will be larger. One of the downsides of this, however, is that the differences between the people that are grouped together will be lost. That, unfortunately, is unavoidable, but at least you can do the test and know that you can rely on the results. Let's say you have a variable, age, that you want to include in a crosstab. In your data, age has 5 possible values and you want to group them into 2 age groups to reduce the number of cells in the crosstab. To decide how to group these categories, you can use a couple of different approaches. One, you can make some assumption about which groups are similar in their behavior or their response to the survey questions. Two, you can try and achieve a balanced sample size across the combined groups, ideally with half the sample in each group or close to it. I would recommend that you use the second approach and go for a balanced sample size because that is your best chance of finding statistically significant differences between the groups. Because small samples have higher sampling error, if one group has a relatively small sample, the sampling error will be higher. So even if there is a difference between the groups, it is less likely to be statistically significant. Therefore, the best chance of finding a significant result is to have as balanced a sample size as possible. How do we do this? We start by looking at the frequency distribution of age and at the cumulative frequency. In the table, you can see that in the sample of 100, 50 people are in the first 2 age groups and the remaining 50 are spread out over the next 3 groups. So if you split the sample with age groups 1 and 2 being combined and 3, 4, and 5 being combined, that would create 2 groups, 18 to 34 and 35 and over. This would split the sample evenly with 50 people in each group. In practice, you may not have exactly half, but try and get as close to it as possible. The way to do this in SPSS is to create a new variable based on the old one and change the values as needed. Make sure to specify that you want to create a new variable so that you don't overwrite the existing one. Here we have labeled the variable value column as old value and created a new column called new value. For each old value for the old variable, we specify a new value for the new variable. SPSS will ask you to name the new variable. Next, you need to specify the new value corresponding to the old value. For old value equal to 1, the new value is equal to 1. For old value equal to 2, the new value is also equal to 1. As a result, all the people who checked age 1 or 2 will now have a single value of 1. That is, they will all be in the same age group of 18 to 34. Similarly, we can set the new value for the remaining groups as equal to 2, and this will put all the people who checked age 3, 4, or 5 in the same age group of 35 and over. What we have discussed till now is the logic behind the recoding. On this slide, you can see the steps in SPSS. In brief, recode into a different variable. Select the variable you want to recode and give the output variable a name. Specify the old and new values one at a time. Click Add and Continue and then OK. One of the SPSS tutorials called Crosstabs and Recoding walks you through an example of this process. Make sure to view that before you go ahead.